So, we will continue our discussion on cloud computing, or rather the different computing paradigms what we were discussing. If you recollect, in the last class we discussed about serverless. So, in this class we will have a little more discussion on serverless computing, specifically emphasizing on some of the popular serverless platform which are available at present, and you can also use those, you can basically handle on those platform to have small experimentation. Most of them give some free credits that providers. So, we will see those platforms, right. What are the basic philosophy and what are the basic architecture, though their basic philosophy is same, but they may differ in some minor aspects. So, what we discussed about is we will be discussing about the serverless computing, little whatever we discussed, little recap of the things, and then primarily we will be taking up three things: AWS Lambda, Google Cloud Function and Azure Functions. So, which are serverless paradigm which are provided by Amazon. AWS Lambda is Amazon is the service provider, cloud service provider. Google provides this Google Cloud Functions, and Microsoft Azure comes up with this Azure Functions, right. So, these are some of the popular. There are several other things, even there are few open source platform also, but these are popularly used, and you can easily create a login and start using it, though that will be chargeable, but they do have some free credits. So, these are the things what we will be discussing. So, just we let us continue our discussion, little bit recap. So, if you recollect, so serverless computing primarily it hides the servers by providing programming abstraction for application builders that simplify cloud development, making cloud software easier to write. So, what it is telling that a developer or a programmer is not bothered about the servers or server related configurations, right. So, it is basically hiding the servers from it, and then providing by providing a programming abstraction for the application builders or application developers, right. So, that this cloud level development becomes much easy. This is becoming important these days, because most of the cases we are moving towards these cloud based platforms, right. So, that the huge proliferation of this cloud based application and cloud based platforms basically triggers the need having a basically a platform where I do not have to bother about the back end configuration, management and etcetera. So, here the focus or the target of the cloud computing, if you see, was system administration, and system administration is one that to make that overall system administration is much easier type of things, right. Like I configure a cloud computing, and then I this basic system administration if I maintain, then people can leverage on those things, right. Whereas serverless basically targets towards the programmers. So, their basic focus is not the administrators, they are the programmers, right. So, in case of a cloud computing, the if we look at that type of personnel we are looking at, the system administrator, here the programmers, right. There are a lot of other features definitely. This change requires the cloud provider to take over many of the operational responsibilities need to run applications, right. So, if you want to give a platform to the programmer, so that they can easily develop, or programmer or developer or builder, so to say, so that they can easily develop their application. So, the responsibility of the cloud service provider is not only now providing VMs etcetera. Now, they have to give them operational responsibility of applications, something it sounds like PaaS, right. So, there also we try to provide this sort of a environment where they can develop their application etcetera. Yes, that is there are overlapping, but we will see that we have seen that there are some differences. So, serverless computing, to this in order to look at the change of focus from servers to applications, right. So, the change of focus is from servers to applications. This paradigm is known as serverless, although remote server etcetera are there, right. So, in order to say that this is not some of the literature mention them as a server full computing, like our traditional or that existing cloud computing framework as server full computing, right. Though that those are that will create confusion. So, we are not want to give names like that, but the serverless wants to emphasize that the now the focus is on the applications, not the servers, right. This phase or this new phase of cloud computing or new paradigm or the variant of this cloud computing will change the way programmers work as dramatically as cloud computing changed the operators works, right. So, if you see or if you are managing your system administration of your or some sort of a system administrator of your organization and looking after system etcetera. Now, once you move to the cloud, the way things has to be done has changed, right. So, similarly, when we look at the serverless, the way the programmers will work will change or programmers or coders or developers will work will change dramatically when we look at the serverless computing, right. So, thus serverless applications are one that do not need any server provisioning, right, but ideally there is no need of server provisioning and do not require to manage servers, right. I do not have to manage servers. Managing servers means managing their not only different type of configuration, OS, network etcetera. We do not have to do that. I need to focus only of my so called business logic, for the logic of the application that is required here, right. Now, in the last session or last class, if you remember, we discussed some of the major players, right. So, 3 major players here: AWS, Cloud, Google Cloud and Azure. There are other things, other still major players like IBM and so on and so forth, right. There are many players, but primarily these are some of the popular things, and they lot of programmers, lot of coders, developers use these platform. That is why we taken up. There is no specific reason for that. You can the philosophy still remains the same, right. So, if we see the virtual servers, so in case of AWS, so we say that as AWS instances or virtual machines and VM instances in case of Azure. Now, so the function or what we say that cloud functions or function as a service, but which basically enables the serverless computing. In case of AWS, we call it Lambda, AWS Lambda service. In case of Google Cloud Functions, and in case of Microsoft Azure, it is Azure Functions, right. And they do have their own databases, though they can connect to other databases like here Amazon DynamoDB is their basic database, which basically have a storage of back to back storage of S3, Amazon S3, whereas in case of Google they have a Google Cloud data store, and Google do have a cloud storage, and in case of Azure have that Azure Cosmos DB, right, as Azure Cosmos database, and in the storage they have S3, they fall back to the S3 or they can utilize the S3 and type of things, right. So, rather our main today's discussion hovers around these 3 functions, right. So, we will see that the philosophically they are same, because all are trying to provide or provision serverless computing platform, and but there may be subtle difference of their working pattern. So, we start with AWS Lambda. So, AWS Lambda is an event driven, right, serverless computing platform provided by Amazon as a part of Amazon Web Service or AWS, right. So, it is a event driven serverless computing platform, right. So, thus if you look at, you need to worry about, thus one need to worry about which Amazon resources to launch or how to manage. Actually, you sorry, there may be there is a typo, you do not need to worry about that AWS resources to launch or how to manage them. Instead, you need to put code on the Lambda and runs, right. So, somehow one that knot is missing. So, one need not to worry about their that how this it will be configured, where to launch and where the resources, how to provision, etc. Need to more worry about that logic of the code and just put the code on the Lambda and it runs, right. So, in AWS Lambda, the code is executed based on the responses of the events on AWS services, such as so as it is event driven. So, that AWS it basically the codes are triggers or codes are Lambda code is executed based on the response of the events in the AWS services, like some like it is add delete files in S3 bucket or HTTP request from Amazon API gateway. So, means there can be lot of type of things which are going on, means events which can trigger, right. So, however, Amazon Lambda can only be used to execute background task as of now. What we see that whenever, so this background tasks come into things, we want to execute those tasks, right. So, what we have seen, it is a event driven serverless computing and some sort of a this function is executed in response to some events, right. So, that is another thing what we see it here, right. So, it can be something in the S3 bucket or HTTP request of Amazon API gateway, etc. Now, if we look at that big picture or the block diagram, and there are components 1, 2, 3, 4, 5 different components marked, we will see that what are the role. So, AWS Lambda function helps you to focus on your core product, right. That means, or on your business logic, and instead of managing operating system access, OS patching, right sizing, provisioning, scaling, etc., which otherwise you need to bother about when you go for our traditional way of cloud computing, right. You or your that cloud administrator needs to bother about, but here you just put your code and it start running, right. So, if we look at the picture, so one is that so this is the overall block diagram. We will see what are the different components. So, first thing you need to upload your AWS Lambda code in any language supported by the AWS Lambda. That means, whatever the AWS Lambda platform supports, you can the code, it can be Java, it can be Python, Go, C hash, and other some of the languages there are supported, right. So, these are which are popular languages which are supported. You can have other means other whichever other language supports by the AWS, you can use it. So, these are some of the in the 2, if you see this the down layer, or if you go up this one like Amazon S3, Amazon API gateway, DynamoDB, Amazon SNS, right. That Amazon kernels and etc. different things are there. You will see these different type of operations. You can have that different AWS services which are there. So, what it is there? It is basically allow you to trigger AWS Lambda. That means, as we see again, that is event driven. So, these events are generated by these things, right. So, AWS Lambda helps you to load code. So, So, this AWS Lambda platform code and the event details on which it should be triggered, right. So, some like as we have seen that two things we are discussing, as we add delete files on S3 bucket, things will be triggered, or HP3 request, HTTP request which is from this Amazon API gateway, that can be triggered, and there can be other triggering things also, right. So, these are the AWS services which can trigger this the AWS Lambda code which you have uploaded, right. So, execute AWS Lambda code when it is triggered by AWS services. AWS charges only when AWS Lambda execute code. Now, the charging is only this whenever this AWS Lambda execute the code, then the billing will be done, not otherwise. That means, whenever it is not triggered and not executing, deciding, it is not there otherwise, right. So, it is not charged. So, if you go to this, what are the different components which we see when we execute a code? One is that this AWS Lambda component when you want to execute the code. One is the function. A function is a program or a script which runs in AWS Lambda, right. So, Lambda passes invocation events into your function, which processes an event and returns to the response file, returns its response, right. So, that means the code you upload. So, there is some event generated by your AWS services, and that is there. So, there are some runtimes. Runtimes allow function in various languages which runs on the same base execution environment, right. So, it helps to configure your functions in runtime. It also matches your selected programming languages, right. So, it is the things whatever the programming languages you are using for the coding. There are event source, and event source is AWS service. What we have seen that AWS in SNS can be one simple notification service or custom service, that this triggers function helps you to execute its logic. Okay. Lambda layers are important distribution mechanism for libraries, custom runtimes, and other important function dependencies. These are the Lambda layers. And you finally need the log stream, allows you to annotate your function code with custom logging statements, and which helps you to analyze the execution flow and performance of the your AWS Lambda code or functions, right. So, that is the log stream for analysis purpose what we do. So, these are the different concept which comes with Lambda. If you see that many of these things are there in there, but in their nomenclature where you go to other type of service provider. And running or executing is straightforward. If you have if you have a login in the AWS is great, otherwise you can create one login, and then basically sort of edit your code and execute. Nothing is required, everything is everything will be managed by the backend this your AWS Lambda backend. Next one we would like to see this Google Cloud Function. As we mentioned, Google also provide this serverless computing. So, Google Cloud Function is a serverless execution environment for building and connecting cloud services, right. So, that is the environment provided. So, with Google Cloud Google Functions, you write simple single purpose functions, right, that are attached to events emitted from your cloud infrastructure and services, right. So, this you can write this in the Google Cloud Function is a triggered when an event being watched in the is fired. So, when again this is also once event is fired, the cloud function is triggered, right. So, the code execute in a fully managed environment. There is no need to provision any infrastructure or worry about the managing the server. So, you see now we are looking at a higher level than the server, like more specifically on the code level, right. Like whatever is request, whatever dependencies etc. are taken care by these platforms, that whether it is Amazon AWS Lambda or Google Cloud Function or as Amazon Azure Function. So, those are taken care by those things. So, this is one very simple overall example or scenario of the functionality. So, we have cloud services. This is the cloud Google Cloud Platform. So, which emits events, like in case of Amazon you have seen that AWS services, right, and various services like Google Cloud Storage, Google Cloud Publication and subscription, PubSub, Stackdriver, Google Data Store, etc. Those are in that different cloud Google Cloud services part, right. And they all have events that happen inside them. For example, if a bucket has got into a new object uploaded into, delete it from the metadata, it being updated, etc. So, those are the events which are being, these are the event generator things. And in case of the function, that is the cloud function, say an event is generated or fired or emitted, the event data associated with the event has information on the basic event, that is the metadata sort of things, events that are associated with that event, metadata for that event. If the cloud function is configured to be triggered by that event, if your cloud function is configured that it will need to be triggered by that event, then the cloud function is invoked or run or executed, right, based on that thing. Right. So, as a part of its execution, the event data is passed to it, so that it can decipher what had caused the event, that is the event source, get meta information for the event and so on, and do this processing, right. So, this is at the part of that cloud function. As a part of the processing, it might also maybe invoke other APIs like it can be a Google API or other external APIs, right. So, while processing the things, it is possible that you want to invoke other APIs, right, not only Google APIs, external APIs, that is possible, right. It can even write back to the cloud services, that is another thing, right. So, if required, it is not a one way traffic, it can write back to the cloud services if required, right. So, when it has finished executing its logic, that is your code, the cloud function mentions it or specifies that it is done. So, it is basically once it is done, it flag that it is done. So, multiple event occurrences will result in multiple invocation of the cloud functions. If there are multiple events, so multiple obviously multiple invocations will be there. This is all handled for you by the cloud functions infrastructure, right. You focus on your logic instead of the functions and be a good means keeping your functions in a single purpose, use minimal execution time, etc. In other sense, you manage your functions in a such a way, it is basically executed in a more efficient way. Do not bother about the environment much, right. So, it is only need to work on that type of programming environment which it supports, and rest is taken care. So, it indicates that your model based in a stateless fashion, right. So, if we look at, so things like it is a stateless fashion, right. So, it's even when the event is there, if your function to be triggered by the event, then it is triggered, right. So, rather you can maintain your state outside this framework, right. So, you can maintain the state in outside the, like in say Memcache or somewhere you can maintain the states. So, what we see that events and the triggering. So, events if you see that they occur in cloud platform services, for example, file uploaded to a storage, a message published in a queue, direct HTTP invocation, etc. This can be that several events, and triggers you can choose to respond to a event via a trigger, right. So, whether you respond to your function. So, trigger is the event plus data associated with the event. Based on the event and the data or the metadata information with the events, the trigger can be fired. Event data, this is the data that is passed to your cloud function when the event trigger results in your function execution. So, once it is executing, so the data to be pass to your function to that is the event data. So, event providers is there, that all that what we have seen, right, different services, right, and that triggers and the data is passed to the cloud functions, that Google Cloud functions where your code are running. So, there are some of the event providers like one is the HTTP, that is the one of the popular things, invoke functions directly via HTTP request, right. So, that is the provider what we see pretty popular, not only here, in other context also. There can be cloud storage, cloud PubSub, as we mentioned. There is a Firebase. Those who have used Firebase, you might have seen that is a database, analytics, authorization, all those things are maintained by this Firebase. Stackdriver, login, cloud, Firestore, Google Compute Engine, BigQuery. So, these are the different cloud services, Google Cloud services, which are quote unquote event providers, right. So, now finally, let us look at that Azure functions, right. So, it is a serverless solution that allows you to write less code, maintain less infrastructure and save on cost, right. Instead of worrying about the deploying and maintaining the servers, the cloud infrastructure providers provides all the up to date resources needed for your applications. So, if you look at the basic philosophy remains same, right. So, concentrate on your code and maintain less infrastructure and less configuration issues and type of things, right. So, that is the bottom line, right. So, user focuses on the piece of code and Azure, like others serverless platform, handles the rest of the things, right. So, a function is a primary concept in Azure function, right. A function contains two important pieces, your code, which can be written in a variety of languages, and some configuration that like function.json which are stored in the function.json and things like that, right. So, for compiled languages, this config file is generated automatically from the annotations in your code. For scripting language, you must provide the configuration itself, right. So, that depends that whether it is a compiled language or a script what you are running, right. So, Azure function helps you in build your own functions. So, there are different resources are available, like use your preferred language, write functions in C#, Java, JavaScript, Python, etc., or you can use a custom handler to use virtually any other language, right. So, those is there, but these are the things which are supported and maybe the more efficiently handled. Automate deployment from a tool based approach to using external pipelines. There is a huge amount of deployment options available, right, good amount of deployment of options available. Troubleshoot a function, use monitor tools and testing strategies to gain insights in your own app. Flexible pricing options with the consumption plan, you only pay while your functions are running, while premium and app service plans offer features of the specialized need. So, that means you pay when it is running. Same thing, if you remember, we discussed when we discussed about Google or Amazon, same thing was there. You pay only for the execution of the this AWS Lambda when it is there, right. Otherwise, you are not charged for the things. So, common serverless architecture plan or architecture pattern is that the serverless APIs, mobile and backends, right. Event and stream processing, IoT data processing, big data and machine learning pipelines, right. And so, we can have different type of backup like serverless API or mobile and web backups or different in-processing event and stream processing, right. Integration and enterprise service, bus to connect line of business systems, publish and subscribe to business events, automation and digital transformation of the process automation, and so on and so forth, right. So, it is so different type of architectural options are there, different types of patterns are there, right. Like if we look at some one two common scenarios like web app backend, what we are looking at is like little scenario where we have request made in a web app, request queued in the service bus, and then go for this function, a function process the request, sends out the output to the Cosmos DB and things like that, right. Or like mobile app backend backend where we have a financial service scenario, right. Like we have HTTP API call from mobile app, call processed by a function, output data goes to this Cosmos DB, and data transfer triggers second functions, right. So, if you want to do a data things, is triggers functions which sends notification to the that notification hubs, etc., right. So, there can be several other scenarios where you have something where the event is generated and this function is triggered, and then output are based on the type of output, the either it is stored or it is means going for, like here output stored in the Cosmos this Cosmos DB, data transfer triggered second function and type of things, right. So, that based on that what sort of applications or what sort of serverless applications you want to run, right. So, with this let us conclude our today's discussion. So, these are some of the references from where I have taken not only the this different figures for this our discussion purpose, and also we have that helps us in coming up with this discussion document. So, what we you can go through these documents, every provider have their own things, and there are a lot of other documents which you will get over the internet. So, let us conclude our discussion, today's discussion here. We will continue this looking at that different computing paradigm in the subsequent classes. Thank you.